The floor you're resting on is not holding you up the way you think it is. The magnet on your fridge is secretly bending space and time. The light reaching your eyes at this very moment is older than it looks, some of it far, far older. And the dark, empty space around you is neither empty nor still. It is silently carrying most of the universe away from you, forever. Every one of those sentences is literally, physically, provably true, confirmed by experiment, and hiding in plain sight in the room you're sitting in right now. Reality presents itself to you, every waking second, as seamless, smooth, solid, obvious, complete. A single unbroken surface with no seams and no gaps. And nearly all of that is a beautifully convincing illusion. Because running through that seamless surface, if you know where to look, are hairline cracks, places where the smooth face of ordinary reality fails, and something far stranger, the way the universe actually works underneath, shows through the gap. These are not mystical cracks, and I am not going to sell you any. They are confirmed, tested, unglamorous facts of physics, and every single one of them is hiding in plain sight, woven into your ordinary life, in the weight of your own body, in the wall you're leaning against, in the light reaching your eyes, in the magnet stuck to your fridge, in the darkness between the stars. You have been living inside these cracks your entire life, and you have almost certainly never noticed a single one of them. And I mean that literally, not poetically. This is not a journey about far-off abstractions or equations on some distant chalkboard. Every crack we are about to open is present in the most ordinary details of your evening, the exact reason your body has weight, the true nature of the wall at your back, the age of the light landing in your eyes, the pull of a magnet you have ignored 1,000 times, the darkness framed in your window. Physicists did not invent these cracks to unsettle anyone. They found them by looking very carefully at ordinary things and refusing to look away when the ordinary stopped making sense. And what they found is that the seamless world is a kind of user-friendly surface, a version of reality simplified just enough for a human being to walk around inside without going mad, and that underneath it, the real machinery is far more alien, far more beautiful, and far more open than the surface ever lets on. Tonight, gently, we lift that surface in 5 places. Tonight, we're going to run a finger, slowly, along 5 of them. And I am going to make you the same promise I always do. I am going to be honest about the size of each crack. Some of what I show you is so solid it underpins the technology in your pocket. And I'll tell you when we're standing on bedrock. And some of these cracks get wildly exaggerated online, stretched into claims the physics does not actually support. Teleportation, time being an illusion, the universe being a simulation. And I'll tell you plainly, each time we reach the edge of what is known and step back from the hype, because the real cracks are stranger and more beautiful than the invented ones, and they have the singular advantage of being true. We'll start with the most constant sensation you have ever felt, the one you're feeling at this exact moment and have never once questioned, the feeling of your own weight pulling you down, because it turns out that nothing is pulling you down at all. Right now, you can feel it, the gentle, unrelenting pull of your body toward the ground, the weight in your legs, the pressure of the seat against you, the effort it would take to stand. It is the most familiar force in your entire life. You have felt it every second since the day you were born, and you are taught quite reasonably that it is a force, gravity, reaching up from the earth and pulling you down, the same invisible hand that keeps the moon circling and the planets on their tracks. It feels so obvious, so directly sensed, that questioning it seems almost absurd. but the first crack is one of the deepest and best confirmed ideas in all of physics. Gravity is not a force. Nothing is pulling you down. That feeling of weight is real, but its cause is the exact opposite of what your whole life has told you. To see the crack, we have to go back to a single thought that Albert Einstein later called the happiest of his life. He imagined a person falling freely, someone who has stepped off a great height, or an astronaut drifting in orbit. And he realized something that should stop you cold. A person in free fall feels no gravity at all. They feel weightless. If you have ever been on a fairground ride that drops you, or felt your stomach lift as a plane hits a pocket of falling air, you have tasted it. In the moment of falling, the sensation of weight vanishes completely. That lurch in your stomach is not fear alone. It is the brief, startled recognition of your body finally getting to do what it always wanted, to fall freely, unopposed, along its natural path. And for those few seconds, with nothing pushing up against you, you feel no weight at all, because in that moment, there is no force on you to feel. The astronaut lives permanently in that lurch, endlessly falling around the Earth and never quite hitting it, and so lives permanently weightless, not because gravity has let go of them, but because nothing is any longer in the way to stop their fall. The astronaut on the space station is not weightless because they have escaped Earth's gravity. Earth's pull up there is nearly as strong as it is on the ground. They are weightless because they're falling continuously in a great curving arc around the planet, and a falling thing feels nothing pulling on it. Sit with how upside down that is, because it inverts everything. The person doing what you'd think requires no force, sitting perfectly still in a chair, is the one who feels gravity, and the person who appears to be violently accelerating toward the ground, the free-faller, feels nothing at all. Einstein took that upside-down clue and followed it to a conclusion that rebuilt our picture of the universe. What if free fall is the natural state, the state of feeling no force, and it is the ground pushing up against you that is the real, felt event? The picture he arrived at is one of the most beautiful ideas humans have ever had. Mass and energy bend the very fabric of space and time around them. The Earth sitting there curves the space-time in its neighbourhood into a kind of valley. Not a valley in space that you could photograph, but a curvature woven through space and time together. And every object simply travels along the straightest possible path through that curved space-time. A thrown ball, the orbiting moon, a falling apple, none of them is being pulled by anything. Each is just coasting along the straightest available line through a landscape that curvature has bent. The moon isn't held by a cosmic string, it's rolling along a straight path in a space that Earth has curved into a circle. You have probably seen the popular picture of this. A heavy ball sitting on a stretched rubber sheet, making a dip that smaller balls roll into. It is a helpful image, and it is also, I have to admit honestly, a little bit of a cheat. That rubber sheet picture secretly uses ordinary gravity. The ball rolls into the dip because real gravity is pulling it down onto the sheet to explain gravity, which is circular, and it shows only space bending, leaving out the far more important bending of time. The truth is harder to draw and less intuitive to hold. It is not mainly space that curves to make you fall, but time. Objects move toward regions where time runs slower, and near the Earth, time runs very slightly slower closer to the ground. Your body, drifting forward through time, as it always does, is nudged by that difference in time's rate toward the ground, and we feel the accumulated result as weight. So the honest version has no rubber sheet and no rolling ball. It has you, moving through time, being steered by the way a nearby mass has bent time's own flow. The picture that fits in a diagram is a shadow of the real thing, which lives in 4 dimensions and refuses to sit still on a page. Left completely alone, with no forces on it at all, an object in curved space-time falls. Falling is what doing nothing looks like near a mass. To feel why physicists are so certain of this, run the thought experiment Einstein built the whole theory on. You can do it entirely in your head. Imagine you wake in a sealed room with no windows, and you feel your ordinary weight pressing you to the floor. Now ask, are you standing on the earth, held down by gravity, or is your sealed room actually far out in empty space, nowhere near any planet, being hauled upward by a rocket at a steady, brisk acceleration, the floor rushing up to meet your feet and pressing on them exactly as a floor on Earth would? Einstein's startling claim is that there is no experiment you could perform inside that sealed room to tell the two situations apart. Drop a ball. In both cases, it falls to the floor at the same rate. Stand on a scale. In both cases, it reads your weight. Pour water. It splashes down identically. Gravity and acceleration are not merely similar. From the inside, they are perfectly, exactly indistinguishable. This is the equivalence principle, and it is the seed of everything. If standing still in gravity feels precisely like being accelerated upward through empty space, then perhaps that is because it is the same thing. The ground beneath you is really accelerating you upward, shoving you off the straight, falling path you would otherwise take. And that little sealed room idea pays off in something we can actually check. Inside the accelerating rocket room, shine a beam of light straight across from one wall to the other. In the tiny time the light takes to cross, the room has accelerated upward a little, so the beam, which travels in a straight line through space, lands slightly lower on the far wall than where it started. From inside, it looks as though the light itself fell, bending downward ever so slightly on its way across. But if the sealed room truly cannot tell acceleration from gravity, then light must do the very same thing in real gravity. It must bend as it passes a mass. And it does by precisely the amount Einstein calculated, first confirmed when starlight was seen to curve around the sun during that 1919 eclipse. Light, which has no mass at all for gravity to pull on, still falls because it too is only following the straightest available path through a space-time that mass has curved. There is one more consequence, and it is the strangest and most beautiful of them all. Gravity bends not only space but time. The deeper you sit in a gravitational valley, the closer to a mass, the slower your time runs, compared to someone higher up. This is not a feeling or a figure of speech. It is measured routinely. Place one atomic clock on the floor and an identical one on a high shelf, and the higher clock, sitting in slightly gentler curvature, ticks faster. Over a lifetime, your head ages a few billionths of a second more than your feet. A real, if tiny, split in the rate of your own time from one end of your body to the other. This is not confined to laboratories either. The satellites of the global positioning system, orbiting high above the Earth, where the curvature is gentler, run their clocks measurably faster than clocks on the ground, by about 38 millionths of a second every single day. That sounds negligible until you realise the whole system pins down your location by timing signals to billionths of a second. Left uncorrected, that daily drift would throw your position off by roughly 10 kilometres within one day, and grow worse every day after. Every time your phone tells you where you are, it is silently correcting for the fact that time runs at different rates, at different heights in a gravitational field. The crack is not merely real, it is engineered around, continuously, inside the device in your pocket. And it means something staggering about the people around you. Someone who has spent their years working on a high floor or living up in the mountains has aged the tiniest sliver more than someone who has lived at sea level, not as a metaphor, but as measurable fact. Height in this universe is a rate of time. You have been living at your own particular altitude in the flow of time your whole life, and everyone at a different height has been aging imperceptibly at a different pace than you. Near something as extreme as a black hole, this gentle effect becomes monstrous. An hour spent close to the hole could be many years for the distant universe. So the weight in your legs is only the most obvious edge of this first crack. The same curvature you feel as heaviness is, at every instant, also stretching and slowing the flow of your own time by an amount too small to notice, and out at the rim of a black hole large enough to tear a single lifetime clean away from the rest of history. And the deepest confirmation of all came only recently. If mass curves space-time, then violently moving masses should send ripples through it, waves in the fabric of space itself, spreading outward at the speed of light. Einstein predicted them a full century ago and doubted we could ever detect something so impossibly faint. Then in 2015, after decades spent building instruments of almost absurd sensitivity, we caught one. Two black holes more than 1 billion light-years away had spiraled together and merged, and the collision shook space-time so violently that the ripple was still measurable when it finally washed over the Earth, stretching and squeezing the entire planet by less than the width of a single proton. We felt the fabric of reality quiver. Space is not a fixed, passive stage. It is a physical thing that can bend and stretch and ring like a struck bell. And we have now, for the first time, heard it ring. Follow the curving to its extreme, and you arrive at the strangest objects in the universe. Black holes where so much mass is crushed into so small a space that the curvature becomes, in effect, bottomless. Get close enough and the falling path, the one your body is always trying to take, tips so steeply inward that there is no longer any direction at all that leads back out. That boundary has a name, the event horizon. It is not a wall and not a surface, it is simply the place where every possible path, even the path of light itself, bends inescapably inward. Cross it, and you are not trapped the way a prisoner is trapped. You are trapped the way tomorrow is trapped. The centre now lies in your future, and there is no more a direction that leads away from it than there is a direction from where you sit right now that leads back into yesterday. That is what extreme curvature finally does. It turns a place into a fate, and it is the very same crack you're feeling, infinitely gentler as the ordinary weight resting in your legs at this moment. So then what is that weight you feel? Here is the crack, fully open. You feel heavy not because something is pulling you down, but because something is pushing you up. The ground, the chair, the floor, physically shoving against you, stopping you from following your natural, straight, falling path toward the centre of the Earth. Your body wants to fall. That's the no-force state, the straight line through curved space-time. The solid Earth is in the way, and it pushes back on you to keep you from taking that path. That upward push from the ground is the only real, felt force in the whole situation. The sensation you have spent your entire life reading as gravity pulling me down is in truth the floor accelerating you upward, away from the free fall your body is constantly trying to begin. You are, at this very moment, being shoved upward by the chair beneath you, and mistaking the shove for a pull. This is not a poetic reinterpretation or a philosopher's word game. It is Einstein's general theory of relativity, and it is one of the most ruthlessly tested theories in the history of science. It predicted that light itself, having no mass at all, would nonetheless be bent as it passed a massive object, because light too follows the straightest path through curved space-time. And in 1919, astronomers measured starlight bending around the sun during an eclipse, exactly as predicted. It predicted that time itself runs slower, deeper, in a gravitational valley, and we have confirmed that with clocks precise enough to detect the difference over a few feet of height. The satellites your phone uses to find your location have to correct for this constantly. If they didn't account for the fact that time runs at a different rate up there in shallower curvature, your navigation would drift off by miles within a day. This crack isn't a curiosity. Your ability to find your way home relies on it being true. And I want to be honest about where the solid physics ends, because gravity is a place where real science shades into genuine mystery, and the two shouldn't be blurred. Everything I've just told you, gravity as curved space-time, your weight as the ground pushing up, is bedrock, confirmed to exquisite precision. What we still do not understand is how this smooth, geometric picture of gravity fits together with the jittery quantum nature of everything else in the universe. At the very centre of a black hole, or in the first instant of the Big Bang, the two great theories of physics contradict each other, and no one yet knows how to reconcile them. So the crack has a bottom we cannot yet see. But the part you can feel, the part in your legs right now, is not in doubt. Nothing is pulling you down. You are simply trying to fall forever, and the world keeps catching you. The next time you sit down and feel your weight settle into the chair, you can feel it correctly now, not as the earth reaching up to pull you, but as the chair reaching up to stop you, interrupting, moment after moment, the endless gentle fall your body has been trying to take since the day you were born. That is the first crack, and the second one is running, right now, straight through the solid wall you believed nothing could pass. Lean back against something solid, a wall, a headboard, the back of your chair. It stops you completely. That is what solid means, a barrier that holds, an edge that things cannot pass. You have trusted this your whole life. Walls keep the weather out. A closed door keeps a room sealed. The cup holds the water. The floor holds you up. Solidity is one of the most basic, reliable facts of the physical world. Objects have boundaries, and other objects do not pass through them. Except that they do. Quietly, constantly, in tiny amounts, the particles that make up you and everything around you are passing straight through barriers that should, by every rule of the ordinary world, stop them dead. This is the second crack, and it has a name, quantum tunneling. It is not a fringe idea or a theoretical maybe. It is happening inside your body right now. It is the reason the sun is shining, and it is running inside the very device you may be listening on. To understand the crack, we have to remember something odd about what the smallest pieces of matter actually are. A particle like an electron is not a tiny solid ball sitting at a definite point. Down at that scale, matter behaves like a wave, a spread out smear of possibility, describing all the places the particle might be found, and how likely each one is. The particle doesn't have one sharp location. It has a cloud of maybe, thick where it is likely to be, and thin where it is unlikely, trailing off in every direction. Now put a barrier in the way, a wall in the particle's tiny world. In the ordinary picture, if the particle doesn't have enough energy to get over the wall, that's the end of it. It bounces back every time. The way a ball rolled at a hill it can't crest will always roll back down. But the particle is not a ball. It is that spread out wave of possibility. And when that wave meets the barrier, it does not simply stop at the wall. It seeps into the wall, thinning as it goes. And if the barrier is thin enough, a faint whisper of that wave leaks out the other side. The probability cloud, dense on the near side, trails a thin tail straight through the solid barrier, and re-emerges, weak but real, beyond it. And because the particle's location is a matter of probability, that thin tail on the far side means there is a genuine, non-zero chance of finding the particle on the other side of a wall it never had the energy to cross. It didn't climb over. It didn't smash through. It was on one side, and then, without ever having enough energy to make the crossing, it is on the other. It tunneled. I want to be careful and honest here, because this is exactly where the internet loves to run off the edge. Tunneling is not teleportation. The particle does not vanish and instantly reappear elsewhere. It doesn't blink out of one place and into another. There is no magical jump. What is really happening is subtler and, to my mind, eerier. The particle's very existence is smeared across the barrier, and the wall, if it is thin enough, simply fails to fully contain something that was never truly located in one spot to begin with. It is less like a prisoner escaping through a wall and more like a fog that a fence cannot quite hold. This leaking through is so fundamental that some molecules run their entire lives on it. The ammonia molecule, for instance, is shaped like a tiny pyramid with a nitrogen atom perched above 3 hydrogens, and the nitrogen constantly tunnels straight through the wall of hydrogens to pop out the other side, flipping the pyramid inside out, billions of times every second, passing through a barrier it hasn't the energy to climb. This relentless, clockwork steady flipping was so reliable that in the 1940s it was used to build one of the very first atomic clocks. Before we timed the universe with anything else, we timed it with a molecule turning itself inside out through a wall. The crack is not an exotic edge case. It is woven so deeply into how matter behaves that we have measured the passage of time itself by it. Keep that picture, because it matters. The crack is real, but it is a crack about what solid and located mean at the bottom of things, not a doorway to science fiction. The idea did not arrive as idle speculation. It arrived to solve a genuine mystery that had stumped physicists for years: radioactivity. Certain heavy atoms, like uranium, spit out particles from their nucleus and slowly transform into other elements. But there was a paradox at the heart of it. The particle being ejected, a tight little clump of matter called an alpha particle, was known to be trapped inside the nucleus by a force far too strong for it to escape. Measured directly, that particle simply did not have the energy to climb out of the nuclear prison it sat in. By every ordinary rule, it should have stayed locked inside forever. And yet, given enough time, out it came. In 1928, the physicist George Gamow realized what was happening. The alpha particle was not climbing out of its prison. It was tunneling through the wall. Its probability wave leaked through the barrier it could never surmount. And every so often, sometimes after seconds, sometimes after billions of years, it re-emerged on the outside and flew free. This is what radioactive decay is: matter tunneling out of the heart of an atom. The glowing dials, the medical scans, the age of the rocks beneath your feet, dated by their slow, radioactive ticking. All of it is this crack at work. The very timekeeping we use to measure the age of the Earth runs on particles escaping through walls they cannot cross, and it reaches astonishingly into life itself. Some of the chemical reactions that keep you alive, the shuffling of electrons and even whole hydrogen nuclei inside your cells, the machinery of enzymes and of photosynthesis in the plants that feed you, appear to run faster and more efficiently than they otherwise could, because particles tunnel across the tiny gaps involved rather than laboriously going over them. There is a real and growing suspicion among scientists that life has been exploiting this crack in solidity for as long as there has been life at all. that the same leaking through barriers powering the sun overhead is also, in a small way, powering the chemistry inside you. The crack is not out there at the fringes of physics. It runs through the light in the sky, the rocks underfoot, the chips in your pocket, and the cells doing the work of keeping you alive. Now, how thin does a barrier have to be for this to happen? For anything the size of a person, the answer is unimaginably, absurdly thin. The wave nature of large objects is so vanishingly slight that tunnelling through anything solid is fantastically improbable. But, and this is the part that unsettles people, it is not impossible. The mathematics does not forbid it. It only makes it staggeringly unlikely. There is a real, calculable, non-zero probability that if you walked at a wall, the countless particles of your body would all, by pure chance, tunnel through it at once, and you would pass to the other side, untouched. The catch is the size of that probability. You would have to walk into the wall not millions of times, not billions, but a number of times so enormous that it dwarfs the number of atoms in the observable universe and the age of the cosmos combined. And even then, you would almost certainly just keep bruising your nose. So no, you are not going to walk through walls. But the reason you can't is not that it's forbidden. It's only that the universe is not old enough, and never will be, for the dice to land that way. The wall stops you not by an unbreakable law, but by overwhelming odds. That is a very different kind of barrier than the one you thought you were leaning on. It is worth pausing on just how staggering those odds are, because the number is a kind of poetry. For a person-sized object to tunnel through a solid wall, every one of the countless trillions of particles in your body would have to leak through at the same instant, all landing on the far side together. The probability of that is not merely small, it is a decimal point followed by more zeros than you could write in 100 lifetimes. If you hurled yourself at a wall once every second, from the birth of the universe until now across the entire age of the cosmos, the chance you'd have passed through even once is so close to zero that the difference cannot be meaningfully expressed. And yet, this is the whole startling point. It is not exactly zero. The barrier that stops you is made of nothing but odds. The law of physics that keeps you on this side of the wall is not a stone commandment. It is a probability so overwhelming that it has never once failed and never once will, but which is, at the very bottom, still only a probability. You are held in the world by statistics, and where objects are small enough for those statistics to swing the other way, we have turned this crack into some of our most remarkable technology. In the exotic, ultra-cold state called superconductivity, where electricity flows with no resistance at all, engineers build tiny devices in which pairs of electrons tunnel across a thin gap in precise, controllable ways. Junctions so sensitive, they can detect magnetic fields 100 billion times fainter than the Earth's, and which now form the beating heart of many of the quantum computers being built around the world. The most advanced machines humanity is currently constructing, the ones meant to compute in ways no ordinary computer ever could, run on particles deliberately, reliably, leaking through walls. The crack in the solidity of the world is not a flaw we have to work around. It has become a tool we are learning to build the future on. In truth, it already built the present one. The transistor, the tiny switch at the heart of every computer, every phone, every digital device on Earth, the component we manufacture by the tens of billions, and which underpins the whole modern world, depends, in its smallest and most advanced forms, on controlling how electrons tunnel through ultra-thin barriers. As we have shrunk these switches smaller and smaller, tunneling has gone from a curiosity to the central design problem. Electrons now leak across barriers only a handful of atoms thick, and much of the art of modern chip making is managing that leakage. There is even a component, the tunnel diode, that works only because of tunneling, and does its job faster than almost anything else precisely by exploiting the crack head-on. Step back and the scale of it is almost comic. The reason you can hear these words at all, the processor decoding them, the memory holding them, the screen you may be reading from, traces back, in the end, to particles slipping through walls they have no business crossing. We did not merely discover the crack in solidity, we wired our entire civilization straight through it, and we live inside the result every waking hour. And this is where the crack stops being a curiosity and becomes something your existence depends on. Look up at the sun. It shines. It has shone for 4.5 billion years, warming this planet, growing every plant, powering nearly every living thing, because of quantum tunneling, and it could not shine without it. Deep in the sun's core, hydrogen nuclei must fuse together to release energy. But nuclei are all positively charged, and like charges repel fiercely. Two protons rushing toward each other are pushed apart by an electric barrier so strong that even at the ferocious temperatures of the sun's core, they simply do not have enough energy to overcome it and touch. By the ordinary rules, fusion in the sun should be impossible. The protons should always be turned away before they meet. And yet the sun burns. It burns because the protons tunnel. Their probability waves leak through that electric barrier they could never climb. And just often enough, two of them find themselves on the other side, close enough to fuse. Every particle of sunlight that has ever fallen on your skin, every calorie of energy in every meal you have ever eaten, exists because particles in the heart of the sun routinely pass through a wall they don't have the energy to cross. The light of our star is powered by the very crack we're standing on, and it is worth pausing to feel how radical this idea was when it first arrived. For all of history before quantum physics, a barrier was simply a barrier. If you lacked the energy to cross it, you did not cross it, full stop. No exceptions, in this world or any other. Tunneling shattered that certainty. It said that the most basic rule of solidity, that a wall you cannot get over stops you, is not absolute, but only usually true. When the first physicists worked this out, many of them found it disturbing. It seemed to let things happen that ought to have been forbidden. But the mathematics was clean, the predictions were exact, and the universe kept confirming them, all the way up to the shining of the sun over your head. Sometimes the deepest cracks in reality announce themselves not with a crash, but with a quiet equation that turns out, against every intuition, to be simply and stubbornly true. It is not only the sun. This same leaking through barriers is not a distant cosmic event. It has been engineered into your daily life. There is a kind of microscope, the scanning, tunneling microscope, so sensitive it can image individual atoms, and it works by measuring the tiny current of electrons that tunnel across the empty gap between its needle-sharp tip and the surface below. The very existence of that current flowing across a gap the electrons shouldn't be able to cross is what lets us see atoms at all. And the memory chips that hold the photos and messages in your phone, flash memory, store information by deliberately pushing electrons through a thin, insulating barrier, using controlled tunneling to trap charge in place. Every photo you've saved, every message you've kept, sits behind a wall that electrons were made to tunnel through on purpose. This crack in the solidity of the world is not just real. We have learned to build with it. So the honest shape of this second crack is this. Solidity, at the smallest scale, is not the hard, absolute boundary it appears to be. It is overwhelmingly reliable, reliable enough to build a civilization on, reliable enough that you will never, ever walk through a door. but it is reliable by probability, not by law. Matter, at the bottom, is not little solid pellets stopped by little solid walls. It is waves of possibility that thin but never quite vanish on the far side of every barrier, which means that every wall you have ever leaned on, every closed door, every solid surface that has ever held you, is very slightly porous to the true, spread out nature of things it's made of. You are not sealed off from the world by hard edges. You're a cloud of maybe, and so is everything around you, and the boundaries between you and the rest of it are quieter and more permeable than any solid thing has ever let you believe. There is something almost tender in that when the oddness settles. The hard line you imagine around yourself, skin here, world there, a clean edge between you and everything else, is, at the finest scale, not a wall but a gradient, a soft fading of one cloud of possibility into another. You're not sealed off inside your own outline. The particles you're made of trail their faint tails into the chair, the air, the light, the world, and the world trails its tails into you. Nothing solid is quite as separate, quite as bounded, quite as shut as it feels. At the very bottom, the universe is far more continuous, far less sharply divided than the crisp edges of ordinary life ever suggest. And you're not a thing sealed off from it, but a slightly denser patch of the same underlying stuff as everything around you. Nothing is pulling you down, and no wall completely stops the world. Hold both of those, because the third crack pulls the ground out from under something even more basic than solidity. It takes away your ability to see the present moment at all. Look at something across the room, anything, a lamp, a doorway, your own hand held up in front of you. It feels utterly immediate. You are seeing it now, in this present instant, exactly as it is. That sense of seeing the world live as it happens is so total that it never occurs to anyone to doubt it. But it is wrong. You are not seeing any of it as it is now. You never have. Not once in your entire life have you seen the present moment. Everything you have ever seen is a picture of the past. And this third crack, once you feel it, rearranges your relationship to the whole world. The reason is simple, and it is one of the most solid facts in physics. Light travels at a finite speed, fast, staggeringly fast, about 300,000 kilometers every second. But not infinite. It takes time for light to cross any distance at all. And since you only ever see anything by the light that has bounced off it and travelled to your eyes, you are always seeing it not as it is when the light arrives, but as it was when the light left. You see everything late. You see everything as it used to be. For things close by, the delay is so tiny it seems not to matter, but it is never zero. The face of a friend sitting across a table from you is reaching your eyes as it was a few billionths of a second ago. Your own hand, held at arm's length, you see as it was a nanosecond in the past. These delays are unfathomably small, far too brief for you to notice, but they are real, and they mean something absolute. There is no distance at which you see a thing in the true present. The present of the world outside you is, quite literally, invisible. You are always looking into the past. The only question is how deep. We have known light was slow for longer than you might guess, and the way we first found out is lovely. In 1676, a Danish astronomer named Ole Rømer was carefully timing the moons of Jupiter as they slipped in and out of the giant planet's shadow. He noticed something puzzling. The eclipses ran late when the Earth was farther from Jupiter in its orbit, and early when it was closer. The moons were not changing their schedule. The light carrying the news of them simply had farther to travel when the two planets were far apart, and so it arrived late. From the size of that delay, Rømer became the first human being to realise that light does not arrive instantly. and even to make a rough estimate of its staggering speed. It was the first proof that seeing is not instantaneous, that the universe has a built-in delay woven into it, and that we have always, without knowing, been watching a slightly old sky. And the moment you look up, the depth becomes staggering. The moon you see hanging in the sky is the moon, as it was about 1 1/3 seconds ago. If it somehow vanished, you would keep seeing it, serenely glowing, for over a second before the last light of it reached you. The sun, the source of nearly all light and life on Earth, you see as it was 8 minutes and 20 seconds ago. Sit with that one. If the sun were, in this instant, to simply wink out of existence, you would have no idea. Nothing would seem wrong. The sky would stay bright, the warmth would keep falling, the world would look completely normal for 8 full minutes. And only then would darkness and cold arrive together, the news of a death that had already happened before you finish reading this sentence. You cannot see the sun as it is. You can only ever see the sun as it was. Push further out, and you're looking not seconds or minutes into the past, but years, centuries, ages. The next nearest star beyond the sun is so far that its light takes more than 4 years to reach us. You see it tonight as it was over 4 years ago. Many of the stars scattered across the night sky are hundreds or thousands of light years away, so the light entering your eye left them before you were born, before your grandparents were born, some of it before there were cities. When you look up at a clear night sky, you're not seeing the universe as it is. You are seeing a vast collage of different pasts, each star showing you a different moment in history, all of it stitched together into a single image that corresponds to no single instant that has ever existed. And some of those stars are right now, already gone, burned out, collapsed, scattered, and yet they still shine in our sky, ghost light from objects that no longer exist and will keep shining for us for as long as it takes the last of their light to arrive. Look at the faint smudge of the Andromeda galaxy, just visible on a dark night, and the light landing in your eye left it 2.5 million years ago, before any human being walked the earth. You are seeing, with your own eyes, a moment older than your entire species. There is something almost unbearably beautiful in that, once you let it settle. Every clear night sky is a time machine you can look up into without any instrument at all. A single glance taking in light that left its sources across a span of thousands, even millions of years. All of it arriving now, together, in your one upward look. You're not seeing the universe. You are seeing its history, layered and luminous, delivered to your eye by the slowness of light. A vast, silent archive of the past, hung over your head every single night, free for anyone who remembers to look up and understand what they're truly looking at. Now I want to turn this crack back toward you, because it doesn't stop at your eyes. Even the world you assemble inside your own head is a reconstruction of a moment already gone. When light finally reaches your retina, the signal still has to travel to your brain and be processed into the experience of seeing. And that takes time too, a good fraction of 1/10 of a second. Your brain, cleverly, edits this delay out. It stitches together a smooth, seamless sense of now and hands it to you as if it were live, hiding the lag so well that you never suspect it. But the now you feel yourself living in was assembled from information that is already, by the time you experience it, a fraction of a second old. You do not live at the leading edge of time. You live a little behind it, always in a present that your own mind has reconstructed from the recent past and presented to you as the current moment. Push this crack to its cosmic extreme, and it gives us something almost unbelievable. A photograph of the universe as a newborn. Because light takes time to arrive, the farther out we look, the further back in time we see. And if we look far enough, we can see all the way back to the young cosmos itself. The most distant light we can detect is a faint glow reaching us from every direction, light that set out more than 13 billion years ago, when the universe was a hot, featureless fog, not yet 400,000 years old. It is, quite literally, a baby picture of everything. The oldest light there is, still arriving, still readable, an image of the infant universe delivered to our instruments by the plain fact that light is slow enough to keep the past alive. We do not have to imagine the early cosmos, we can look at it because its light is only now getting here. And there is a subtler edge to this crack, one that dissolves a thing you've always taken for granted, the idea of a single, universal now, ticking away across the whole universe at once. If you cannot see any distant place, as it is in the present, only as it was when its light left, then the notion of what is happening right now on a far-off world becomes a question with no clean answer. There is no master clock hanging over the cosmos, no shared instant that everything everywhere occupies together. Each of us sits at the tip of our own incoming cone of old light, seeing a personal collage of pasts, and the now of a galaxy a billion light years away is simply not something we can point to or share. It is not that their present is hidden from us. It is that a single universe-wide present was never a thing the universe actually had. We each carry our own edge of time, and they never perfectly line up. There is even a quiet human version of the crack, because light and the nerve signals that carry it into experience take time. Everyone you have ever looked at, you have seen slightly in their past, and they have seen you slightly in yours. In any conversation, you are each perceiving a version of the other from a few billionths of a second ago, your minds meeting not in a shared instant, but across a tiny, unbridgeable gap of time, forever just behind the true present of the person in front of you. It changes nothing about love or friendship, or the reality of the person across the table. But it is true, you have never met anyone in the actual present moment. You have only ever met their recent past and they yours. And this crack sets a hard boundary on how much of the universe you could ever, even in principle, come to know. Because light takes time, and the universe has existed for only a finite span, a little under 14 billion years. There is a maximum distance from which light has had time to reach us at all. Beyond it lies more universe, possibly infinitely more, but its light has simply not had long enough to arrive since the beginning of time. We sit at the centre of a bubble of visibility, the observable universe, not because we are special, but because every point sits at the centre of its own such bubble, able to see only as far as light has managed to travel toward it. Everything past the edge of that bubble is not merely far away. It is, for now, entirely unknowable, sealed off by nothing more exotic than the slowness of light and the youth of the cosmos. The night sky you can see is not the universe. It is only the part of the universe whose news has reached you yet. No telescope, however vast, can show you the rest, not because it is too dim to catch, but because its light is still on the way, and some of it forever will be. You are looking out from inside a small bright bubble of arrived light, ringed by an ocean of universe, whose messages have not yet had time to cross the gap. And if you imagine the crack at least spares your own body, that surely you, at least, you experience in the present. It doesn't. The signals from your senses travel to your brain at a finite speed too, along nerves far slower than light. When you stub your toe, the news of it must travel all the way up your leg and spine to your brain before you feel anything at all, and that takes a real, measurable slice of time, longer than the news from your fingertip, because your toe is simply farther away. Your brain, remarkably, seems to hold and align these arriving signals so that a touch on your nose and a touch on your foot feel simultaneous, even though the foot's message had farther to travel, smoothing over the delay so seamlessly that you never suspect it is there. But the raw truth underneath is that you do not even feel your own body in the present. You feel it a fraction of a second late, each part of you reporting in from its own small distance, your unified sense of now stitched together by a brain editing out the lag. Even a mirror shows you the past, or your reflection is old light, your own face always a few billionths of a second behind. There is no vantage point anywhere, not even inside your own skin, from which the present is directly available. Now is the one place you can never actually stand. And, as always, I have to be honest about how far the crack really goes, because this is a place people love to overread. It is tempting to leap from "you always see the past" to "therefore time is an illusion," or "therefore the present isn't real," or "therefore nothing you perceive exists." None of that follows, and I'm not going to sell it to you. The sun is really there, right now, doing what suns do. The face across the table is really present. The world is not a phantom. What the crack actually shows is narrower and truer, that seeing is not the instant, direct contact with reality it feels like. It is the reception of old news, always delayed more the farther away a thing is, so that your visual world is not a snapshot of a single present, but a layered archive of many different pasts arriving together. Reality is real. Your access to it is just never quite leave, and the delay goes deeper than seeing, because the speed of light is not merely the speed of light. It is the universe's absolute limit on how fast anything can travel. Not just light, but any signal, any influence, any cause reaching out to make an effect. Nothing in the universe can outrun it, which leads to a startling consequence. If the sun were somehow to vanish this instant, the Earth would not only keep seeing it for 8 minutes, it would keep orbiting it for 8 minutes, held in a circle around a star that is no longer there, because even gravity's influence cannot arrive any faster than light. The Earth would not know, by any means whatsoever, that the sun was gone until those 8 minutes had passed. The delay is not a quirk of eyesight. It is stitched into the structure of cause and effect itself. The universe has a maximum speed at which one thing is allowed to matter to another, and every relationship in it, every pull, every push, every glimpse, is subject to that same patient lag. There is something oddly gentle in that. Once the vertigo passes, you are at every moment surrounded by history, bathed in light that has been travelling toward you for seconds, for years, for millions of years, each ray a message sent from a moment that will never come again. The universe you see is not a cold, instantaneous fact. It is a vast, slow correspondence, and you're always reading letters that were sent long ago. The present moment of the wider world is forever just out of reach, hidden behind the time it takes for light to cross the gap between you and everything else. You have never seen now, you have only ever seen then. Nothing pulls you down, no wall fully stops the world, and you have never once glimpsed the present. 3 cracks, and the 4th is the one you have looked at 10,000 times, without ever suspecting it was there. It is stuck right now to the door of your fridge. Go in your mind to the most ordinary object you own, a magnet stuck to the door of your refrigerator. You have seen 1,000 of them. A child's toy, a holiday souvenir, a clip holding up a photo. It is the least mysterious thing imaginable. And yet a fridge magnet is performing something so improbable that when you understand what it truly is, it becomes, to my mind, the most astonishing object in your home. This is the crack you have looked straight at, over and over, your entire life, and never once noticed. Start with something you can feel for yourself, That small magnet, weighing a few grams, holds itself against the door, and in doing so, it effortlessly defeats the gravitational pull of the entire planet Earth. The whole mass of the world beneath you is pulling that magnet down, and a chip of metal you could close in your fist holds it in place without the slightest strain. That alone should give you pause. The magnetic force from something so small is overwhelmingly stronger than the gravity of a planet. Magnetism feels like its own separate power in the world, invisible, reaching across empty space, pulling and pushing with no contact. For most of history, that is exactly what it was thought to be. A distinct force of nature, one of the fundamental powers, entirely its own thing. It isn't. And the crack, the thing almost no one is ever told, is this. Magnetism is not a separate force at all. There is no such thing as the magnetic force standing on its own. Magnetism is what electricity looks like when you view it from a moving point of view. It is a shadow cast by ordinary electric charge through the subtle machinery of Einstein's special relativity. That toy on your fridge is not demonstrating some independent magnetic power. It is demonstrating relativity, the same warping of space and time that governs astronauts and near-light speed travel, sitting at eye level in your kitchen. Let me show you how that can possibly be true, because the how is where the beauty is. It comes down to two facts you already half know. The first is that electricity and magnetism are deeply linked. A moving electric charge creates a magnetic effect, which is why running electricity through a coil of wire makes an electromagnet. The second is odder. Einstein showed that for objects in motion, space itself contracts slightly along the direction of movement. Lengths get shorter from the point of view of someone the object is moving relative to. At everyday speeds, this contraction is far too tiny to notice, but it is real and it never fully switches off. Now put those two facts together inside a simple wire. A wire carrying a current is, overall, electrically neutral. It has just as many positive charges sitting still in the metal as it has negative electrons drifting along it, and their pushes and pulls cancel out perfectly. To you, standing still beside it, the wire has no net electric charge, and so it exerts no electric force on a nearby charged particle. But now, imagine you're a charged particle moving alongside that wire, keeping pace with the drifting electrons. From your moving point of view, everything changes. The electrons now look still to you, but the positive charges, which were still before, are now the ones moving, and relativity's contraction squeezes them slightly closer together in your frame of view. Suddenly, from where you sit, the wire is no longer perfectly balanced. The positive charges are packed a hair more densely than the negatives. The wire, which looked electrically neutral to the person standing still, looks electrically charged to you, and so it pushes or pulls on you with a plain electric force. That force, the one that appears out of nowhere the moment you start moving, born purely from relativity, slightly rearranging how the charges are spaced, is exactly, precisely, the thing we call magnetism. The person standing still says, "There's no electric charge here, so the particle must be feeling a magnetic force." You, moving alongside, say, "There's no magnetism here at all. The wire is simply electrically charged and pushing on me." You are both right. You are describing the very same event from two points of view, and what one of you calls magnetism, the other calls plain electricity. Magnetism is not a separate force. It is electricity, seen from a moving frame, through the lens of relativity. Now you might reasonably object. The electrons in a wire drift incredibly slowly, slower than a walking snail. So how could a relativistic effect, which only matters near the speed of light, produce a force strong enough? to hold a magnet against the whole Earth? Here is the gorgeous answer. The relativistic effect on each individual charge is indeed unimaginably tiny at those crawling speeds. But a wire, or a magnet, contains a staggering number of charges, something like 1 trillion of them. And when you add up that fantastically tiny per charge effect across that fantastically huge number of charges, the vanishingly small becomes something you can hold in your hand. The magnet on your fridge is what happens when a nearly imperceptible consequence of the structure of space and time is multiplied by an astronomical number of particles until it grows strong enough to defy a planet. The unifying of these two forces is one of the great stories in science, and it unfolded across a single century. In 1820, a Danish physicist named Hans Christian Ørsted was giving a lecture when he noticed, almost by accident, that a compass needle twitched whenever he switched an electric current on and off nearby. Electricity somehow moved magnets. A decade later, Michael Faraday found the mirror image. Move a magnet near a coil of wire, and you generate an electric current. The two forces kept reaching into each other's territory. Then in the 1860s, James Clerk Maxwell wrote down a set of equations that bound electricity and magnetism together into a single thing, the electromagnetic field. And when he examined those equations, something fell out that he had not put in. They predicted waves, ripples in the electromagnetic field, spreading through space at a very particular speed. Maxwell calculated that speed, and it came out to exactly the speed of light. The conclusion was inescapable and staggering. Light is an electromagnetic wave, the light letting you see, the warmth of the sun on your skin, the radio signals in the air around you, the X-rays in a hospital, the microwaves warming your dinner. All of it is the same thing, ripples in the one electromagnetic field, differing only in how fast they wave. Einstein's relativity then completed the picture, showing that electricity and magnetism weren't just linked but were literally the same force wearing two faces depending on your motion. So the crack on your fridge opens onto almost everything. The compass that has guided travellers for 1,000 years points north, because the Earth's molten iron core, churning and flowing, is an electric current on a planetary scale, wrapping the whole world in a magnetic field. The shimmering curtains of the aurora are charged particles from the sun, spiralling down that field into the upper air. Every electric motor that spins, every generator that lights a city, works by trading between electricity and magnetism, the way Ørsted and Faraday first glimpsed. And the very light entering your eyes as you take all this in is a wave in the exact same field the magnet is tugging on. That small toy holding up a photograph is connected through one unbroken chain of physics to sunlight and starlight and every colour you have ever seen. You were never looking at a trinket, you were looking at one visible handle on the single force that lights the universe. There is a deeper idea hiding in here too, one that changed how physics pictures all of reality. When Faraday tried to make sense of how a magnet could push another magnet across empty space, with nothing whatsoever touching, he invented a concept we now take entirely for granted: the field. The magnet, he proposed, fills the space around it with an invisible condition, a field, present at every point. And it is that field that pushes on anything magnetic nearby. There is no spooky reaching across a gap. There is a real physical field bridging it. This became one of the most powerful ideas in all of science. The universe in the modern picture is filled everywhere with fields, and the particles you're made of are themselves little knots and ripples in those fields. And the messenger of the electromagnetic field, the tiny packet that carries its push from one charge to another, and which also happens to be the very stuff of light, is the photon, a single grain of light, varying both the force and the sunshine. So the magnet's pull, the glow of the lamp, the warmth of the sun, and the signal reaching your device are not four separate things. They are one field, one force, one family of ripples, captured by one set of equations. The long dream of physics has always been to find the few deep unities hiding beneath the many surface appearances. My Kirche and the humble magnet on your fridge is a spot where two of the great forces of nature fold into one, right there in front of you, if you only know how to look. And Maxwell's discovery carried a prophecy folded inside it that shows just how deep this crack runs. If light is a wave in the electromagnetic field, his equations implied, then there ought to be other such waves at every other frequency. Waves far slower than light's visible flicker, and waves far faster. In 1887, a young physicist named Heinrich Hertz went looking and found them. Invisible electromagnetic waves he could make with an electric spark and catch clear across his laboratory, what we now call radio waves. He had produced, out of pure theory, the first radio transmission, and he famously saw no use for it whatsoever. Within a few decades, it would carry voices across oceans. Today we know the whole family. Radio, microwaves, infrared, the thin band of visible light your eyes happen to catch, ultraviolet, X-rays, gamma rays, all of it one single continuous spectrum, all of it the same electromagnetic field waving at different rates. All of it, at bottom, the same thing as the pull of the magnet on your fridge, the light you see by, the warmth you feel, the signal that reached your device, the X-ray that images your bones, the radio filling the air around you unseen. One force, one field, wearing an entire wardrobe of disguises. The crack you found on the fridge door opens, in the end, onto very nearly every way the universe has of reaching across a distance to touch you. And we have made this unified force do extraordinary work. The trains that float above their tracks on magnetic fields, gliding without touching them. The machines in hospitals that use enormous magnets to map the soft tissue inside a living body without a single cut. The hard drives that stored a generation's memories in patterns of magnetism. The wireless signals threading invisibly through the air around you at this moment, carrying voices and pictures, and this very narration, all of it is the same electromagnetism, the same crack, the same union of electricity and magnetism and light that the little toy on your fridge is demonstrating. We did not just understand this crack, we built a great deal of the modern world inside it, and most of us never once noticed what it truly was. You are feeling relativity, not in some exotic laboratory, not aboard a spacecraft, but made large and tangible by sheer number in a child's toy. And I'll be honest about the shape of this crack, because it's easy to misstate. This does not mean magnetism isn't real. It is entirely real. You can feel it hold the magnet. It means only that magnetism is not fundamental and separate. Electricity and magnetism are two faces of a single thing, which physicists accordingly call the electromagnetic field, and which face you see depends only on how you're moving relative to the charges. This is not a fringe reinterpretation. It is textbook physics, one of the triumphs of Einstein's 1905 paper. The very same paper that gave the world the relativity of time and the famous equation linking mass and energy. Magnetism, being a relativistic shadow of electricity, is as solid as any of it. In fact, this exact crack was the doorway through which relativity itself first entered the world. Einstein's famous 1905 paper was not titled anything about time or space. It was called plainly On the Electrodynamics of Moving Bodies, and it opened by puzzling over precisely this. The fact that a magnet and a wire seem to obey different rules depending on which one you imagine is moving, even though only their relative motion should matter. Chasing that small inconsistency, this very crack, the one on your fridge, is what led him to overturn the nature of space and time altogether. The most ordinary object in your kitchen is standing at the exact spot where one careful person, refusing to ignore a tiny discrepancy, pulled a thread and unravelled our entire picture of reality. Great revolutions in physics do not always begin with the stars. Sometimes they begin with a magnet, and someone stubborn enough to ask why it works. So the next time you pass your fridge, look at that little magnet for a second longer than usual. It is not a trinket. It is a small, patient demonstration that space and time bend with motion, that the same deep weirdness governing the fastest things in the universe is sitting on your kitchen door, holding up a photograph. You have walked past this crack 10,000 times. Now you can see it. And the fifth and final crack is the largest of all, so large that it is slowly, silently carrying most of the universe out of reach forever. Here is the last and largest crack, and it runs not through your body or your kitchen, but through the empty space between the galaxies. The vast, dark, seemingly changeless void that fills almost the entire universe. That emptiness looks like the most stable thing there is, a fixed, silent stage on which the stars and galaxies sit. It is not fixed, it is not silent. That empty space is growing, being created moment by moment, everywhere at once. And as it grows, it is slowly, gently, and permanently carrying most of the universe beyond our reach forever. The cosmos you can see tonight is the most of it you will ever get to see. From here on, the view only empties out. Start with the discovery itself, because it is one of the great shocks in the history of science. A century ago, almost everyone, including Einstein, assumed the universe was static, eternal, and unchanging on the largest scale. Then astronomers looked carefully at the distant galaxies and found something impossible to ignore. Nearly all of them are rushing away from us. And not randomly. The farther away a galaxy is, the faster it is receding. Double the distance, and you double the speed of retreat. This is not what you'd see if galaxies were simply flying apart through space from some central explosion. It is what you'd see if space itself were expanding, if the distance between every pair of galaxies were steadily stretching, so that the farther apart two things already are, the faster the growing gap between them widens. This is the single most important thing to understand about the expanding universe, and it is where nearly every popular telling goes wrong. So let me be careful. The galaxies are not flying outward through space like debris from a bomb. Space is not something they are moving through to get away from us. Space is the thing that is growing everywhere, between everything, all at once. Imagine dots drawn on the surface of a balloon. As you inflate it, every dot moves away from every other dot. Not because the dots are travelling across the rubber, but because the rubber itself is stretching between them. From the point of view of any single dot, all the others flee, and the distant ones flee fastest. There is no centre, there is no edge the galaxies are rushing toward, and there is no outside either, no wall the universe is expanding into, no empty room it is gradually filling. That is perhaps the hardest part to picture, because everything in our experience that grows into some surrounding space. But the expansion is not the universe getting larger within some bigger container. It is the container itself, space, stretching everywhere at once, with nothing beyond it into which it needs to grow. A loaf of raisin bread rising in an oven is the closest ordinary image. As the dough swells, every raisin drifts away from every other, the more distant ones separating fastest, not because the raisins move through the dough, but because the dough between them is expanding. The galaxies are the raisins, space is the dough, except that this loaf has no crust and no edge, and sits in no kitchen. There is only the endless rising, everywhere at once, with no outside to rise into. Every point sees the same thing, a universe expanding away in all directions, with itself apparently, but only apparently, at the middle. The Big Bang was not an explosion that happened at one place in space. It happened everywhere in space at once, because back then all of space was compressed together, and it has been swelling ever since, right here included. How could anyone possibly know that space is stretching? The evidence is written in the colour of distant light. As light from a faraway galaxy crosses the growing gulf between it and us, the expansion of space stretches the light wave itself along the way, pulling its wavelength longer, shifting its colour toward the red end of the spectrum. The farther the light has travelled, the more space it has crossed, and the more stretched the redder it arrives. This redshift is measurable with great precision, and it is the fingerprint of expansion. The more distant the galaxy, the redder its light, exactly as a universe with stretching space demands. It was a Belgian priest and physicist, Georges Lemaitre, who first worked out in the 1920s that Einstein's own equations described an expanding universe, and the astronomer Edwin Hubble, who soon confirmed, galaxy by galaxy, that the more distant ones really are receding faster. Einstein had actually altered his equations to force the universe to hold still, so convinced was he that it must be eternal and static. He later called that fudge the greatest blunder of his life. The universe was expanding all along. He simply couldn't believe it, and run that expansion backward, like a film in reverse, and it tells us where everything came from. If space is stretching and the galaxies are all drifting apart, then long ago they must have been packed closer together, and further back still, closer yet, until everything we can now see was crushed into an unimaginably hot, dense state, and space itself was compressed almost to nothing. That searing beginning is what we call the Big Bang, not an explosion of matter flying out into a waiting emptiness, but the very first moment of an expansion that has never stopped, when all of space was compact and scorching, and began, everywhere at once, to swell and cool. We are not watching the debris of an old explosion drift apart. We are living inside an expansion still in progress. The same stretching of space that began everything is the stretching that is, right now, carrying the far galaxies away. The beginning and the disappearing are the same process, seen at two different ages of the world. And if we follow that expansion forward, far past the disappearing of the galaxies, we arrive at the long, cold fate that most likely awaits everything. As the ages stretch on, the stars will one by one exhaust their fuel and gutter out. New stars will stop forming as the raw gas runs low. The galaxies will fade from brilliant wheels of light to dim graveyards of dead stars and cinders. Even the black holes, the last dense remnants, will over unfathomable spans of time slowly evaporate away into nothing. The universe drifts toward a state astronomers call the heat death. Not fire, but its opposite. A vast, thin, freezing darkness, spread ever more emptily across ever more space. Every last spark of usable energy exhausted. Nothing left that can happen. It is the quietest possible ending. I'll be honest that the very far future is not certain. It hinges on what dark energy really is. And since we don't know that, we can't be sure the story ends exactly this way. But on our best current understanding, the universe is not headed for a bang or a crunch. It is headed for a long, slow, silent cooling into the dark. The disappearing you and I are watching begin is the first faint edge of that. There is a strange privilege buried in this, and I want to name it plainly because it turns the whole bleak picture into something closer to gratitude. We happen to exist in the brief cosmic chapter when the universe is still readable, old enough to have grown stars and planets and minds, but young enough that the galaxies have not yet fled beyond the horizon, and the evidence of the beginning still lingers in our skies. A civilization arising in the deep future, on some lonely world in the last lit galaxy, would look out at a sky of perfect, featureless black. No other galaxies, no ancient afterglow, nothing at all to hint that the cosmos was ever anything but their single island of stars adrift in an eternal, empty dark. They could do excellent physics and still never discover the expansion, never find the Big Bang, never learn the true story of where they came from, because the clues themselves will have expanded clean out of view. They would be marooned in a smaller, simpler, false universe, with no way of ever knowing it. We are not. We were handed the rare gift of being awake during the age when the universe still tells the truth about itself. When you can still step outside on a clear night and see with your own eyes other galaxies, the light of a cosmos that has not yet forgotten its own origin. That window is open now. It will not stay open forever, and you are alive inside it. There is one honest uncertainty worth adding right at the edge of this crack, because the universe's ending is not fully written. Everything hangs on what dark energy turns out to be, and since we don't know, more than one ending stays possible. On the most likely current reading, dark energy holds roughly constant, and we get the long, slow, freezing dark I described. The big freeze, galaxies drifting apart, stars guttering out, an ever emptier cold. But if dark energy were instead to strengthen over time, the expansion could eventually grow so violent that it tears apart not only the galaxies, but everything. Solar systems, planets, and finally atoms themselves, in a finale physicists have named, with grim flair, the Big Rip. And there are gentler possibilities too, in which the acceleration someday eases. I won't pretend we know which it is. We don't. And anyone who tells you the fate of the universe with certainty is selling something. What we do know is the shape of the near term, and it is the disappearing, already underway, the slow, silent widening of the dark, the far galaxies beginning their long drift toward the horizon. The ending is uncertain. The vanishing is not. It has already begun in every stretch of empty space tonight. Now follow that stretching to its unavoidable conclusion, because this is where the crack opens into something vertiginous. If the more distant a galaxy is, the faster the space between us and it grows, then there must be a distance at which that growth becomes so fast that the gap widens faster than light itself can cross it. And there is, beyond a certain range, a boundary called the cosmic horizon. Space is expanding so quickly that light leaving a galaxy out there can never, ever reach us. It sets out toward us across the void, and the void between us and it grows faster than the light can travel, so the light falls perpetually behind. Like a swimmer trying to reach a shore that is receding faster than they can stroke, that galaxy is not hidden or far away. It is causally severed from us, cut off, permanently, with no signal, no light, no influence able to bridge the gap ever again. And I have to pause to be honest, because your instinct is screaming that this breaks the rule that nothing can travel faster than light. It doesn't. And the reason is subtle and beautiful. Nothing is moving through space faster than light. Those distant galaxies are barely moving through space at all, from their own point of view. They sit peacefully in their own patch of the cosmos. It is the space between us that is expanding, and the expansion of space itself is not bound by the cosmic speed limit. The rule Einstein gave us forbids any object from racing through space faster than light. It says nothing about how fast new space can appear between two objects. So galaxies can recede from us faster than light, without a single one of them ever breaking a law of physics. The universe is not cheating. It is doing something the naive rule never covered. Then in 1998, the story took a darker turn. Astronomers measuring the expansion expected to find it gradually slowing down, gravity gently putting on the brakes as all the matter in the universe pulled back on itself. Instead, they found the opposite. The expansion is speeding up. Something is pushing space apart faster and faster as time goes on. A mysterious property of empty space itself that we have named dark energy for lack of any real understanding of what it is. And let me be completely straight about that name, because it is a confession dressed as an explanation. Dark energy is a label we put on our ignorance. We know from careful measurement that the expansion is accelerating. We know this unknown something makes up the majority of the entire energy content of the universe, and we do not know what it is. It is arguably the single deepest unsolved mystery in all of physics, not a settled fact, but a genuine, gaping hole in our understanding, and I won't pretend otherwise. The discovery earned a Nobel Prize and left us more confused than before, which is sometimes exactly what real science does. But the consequence of that acceleration, if it continues as it appears to be doing, is not in doubt, and it is the quiet tragedy at the bottom of this final crack. As the expansion speeds up, that cosmic horizon, the boundary beyond which things are lost to us forever, is drawing inward. One by one, over the long ages to come, the distant galaxies are crossing it. Their light stretches and dims and reddens as the space it travels through grows, until at last it fades out entirely, and the galaxy slips past the horizon and is gone, not destroyed, simply carried beyond any possibility of contact, forever. The universe is not filling up, it is emptying out. Every galaxy we can currently see is a galaxy on its way out the door. And here is the part that I find haunting and that turns this crack from cosmology into something almost personal. We happen to live at a time when the universe is still full, when the night sky to a great enough telescope is crowded with galaxies, and the faint afterglow of the Big Bang still washes over us, and the evidence of how everything began is still there to be read. But that will not last. In the unimaginably far future, long after our sun is gone, the accelerating expansion will have carried every other galaxy beyond the horizon. A civilization arising then, on some world in some far future galaxy, will look out and see only their own island of stars, surrounded by perfect, endless, empty black. No other galaxies, no afterglow, no evidence anywhere they could point a telescope that the universe was ever anything other than a single static cluster of stars in an eternal void. The very facts that let us reconstruct the history and origin of the cosmos will have expanded out of view. They would have no way of knowing about the Big Bang, no way of discovering the expansion, no way of learning the true story of where they came from. The universe, in a sense, is slowly erasing the evidence of its own beginning, which means something precious about the moment you are alive in. You exist in a narrow, luminous window of cosmic time, late enough that stars and planets and living minds have had time to form, but early enough that the universe has not yet emptied out, not yet forgotten itself, not yet hidden its own history. You can still look up and see other galaxies. You can still detect the first light of creation. You happen to be here while the universe is still legible, still full, still telling the truth about itself to anyone who looks, and that will not always be so. The disappearing is slow beyond all human time scales. The sky will not empty in your lifetime or your species, but it is happening, silently, in every patch of dark space, right now. The void is growing, the universe is disappearing, and you are here, improbably, to see it while it lasts. Before we gather these up, it's worth asking the obvious question. If all 5 of these cracks are real, confirmed, tested, threaded right through your ordinary life, then why did you never notice a single one of them? Why does reality feel so seamless when it is so thoroughly fractured underneath? The answer is that your senses and the common sense built on top of them were never designed to show you the truth. They were designed to keep your ancestors alive. Evolution shaped human perception for one narrow slice of reality. The middle world of medium-sized things moving at walking speeds over spans of seconds and years in the bright, warm light of a single planet. In that middle world, every one of these cracks is invisibly small. Gravity's curving of time is far too slight to feel. Tunneling is far too rare to matter to a body your size. The delay in the light reaching your eyes is far too brief to notice. The relativistic origin of a magnet's pull is buried under trillions of charges. The expansion of space is far too slow and too distant to see in a human lifetime. None of these cracks ever threatened a hunter or helped a gatherer, so nothing in us was ever tuned to detect them. Our common sense is not a window onto reality. It is a survival tool, exquisitely fitted to the middle world and blind to everything above and below it. Go too small, and matter dissolves into waves of probability that leak through walls. Go too fast, and space contracts and time slows. Go too large, and space itself bends and stretches and grows. Go too far, and the present becomes unreachable, and the sky fills with the past. Every one of these regimes was completely irrelevant to staying alive on the African savannah, so our minds were simply never furnished with any feel for them. What we call obvious is only obvious at human scale, human speed, human span. Step outside that narrow band in any direction, smaller, faster, larger, farther, and the obvious stops being true, and the cracks begin. Which is why the cracks stayed hidden until we built instruments sharper than our senses, clocks precise enough to catch time bending, detectors sensitive enough to see a particle leak through a wall, telescopes deep enough to watch the galaxies flee. We are the first creatures in the history of life to see past the edges of our own perception, to catch reality in the places where it stops behaving the way it looks. The cracks were always there. Every human who ever lived was living inside them. We are simply the ones who finally learned where to look. And that may be the strangest and most hopeful fact of all. A creature shaped by evolution for a narrow slice of the middle world, for fruit and predators and weather, for medium things at medium speeds, has somehow reached out past every limit of its own senses and touched the truth anyway. We have felt time bend with clocks finer than any nerve. We have caught single particles leaking through walls. We have weighed the invisible dark that fills the cosmos and heard the fabric of spacetime ring like a bell from a collision 1 billion years gone. None of that was ever available to sight or touch or common sense, and yet here we are, knowing it. The cracks kept reality's deepest strangeness, hidden from our senses for the whole history of life. And then a few stubborn minds, armed with mathematics and patience and instruments sharper than themselves, found the seams anyway. You are one of those minds tonight, holding in your awareness a reality far larger than the one you can feel. So let's stand back and look at the whole cracked surface at once, because here is the quiet astonishment of it. You are not standing near these 5 cracks. You are living inside all 5 of them at every single moment, including this one. Feel your weight in the chair. That is crack 1. You are not being pulled down. You are falling through curved space-time forever, and the seat is shoving you upward, off your natural path. Lean against the wall behind you. That is crack 2. Its solidity is a matter of overwhelming odds, not absolute law, and the true, spread-out nature of its matter is leaking faintly through it even now. Look at anything in the room. That is crack 3. You are seeing it a sliver of a second in the past, and everything beyond your window, out to the ancient galaxies, is older light still, so that you have never once glimpsed the present of the wider world. If there's a magnet anywhere near you, that is crack 4. A piece of relativity made large enough to hold in your hand. The same warping of space and time that rules the stars, sitting on your fridge. And the dark beyond your window is crack 5. Space itself, swelling silently, carrying the far galaxies toward a horizon they will never return from. Weight, wall, light, magnet, sky. 5 cracks, all of them open, all of them running through this exact moment, through your body, through the room you're in. And I keep calling them cracks, but I want to leave you with a gentler way to hold that word. A crack in a wall is a flaw, a sign the smooth surface has failed. But these are not flaws in reality. Reality is not broken. The only thing that breaks at each of these 5 places is the illusion, the seamless, obvious, common sense picture your senses hand you to help you get through the day. The crack is simply the spot where that comfortable illusion gives way and lets the deeper truth show through. So they are not really cracks at all. They are windows. The smooth, solid, seamless world was never the real thing. It was the painted over surface. And notice that these are only 5. I chose 5 because 5 is enough to feel the pattern, not because the cracks run out at 5. Physics is riddled with them. The deeper you look, the more the smooth surface gives way, until you begin to suspect that the seamlessness was always the unusual thing. The thin exception and the strangeness underneath is simply what reality is actually like when you look closely enough. The 5 we traced tonight are not a complete list. They are 5 windows in a wall that turns out to be almost entirely windows. If only you have the instruments and the patience to find them. And at these 5 places, and at every other crack physics has ever found, the paint has worn thin enough to see through to what was always actually there, which is why none of this needs to unsettle you as you drift towards sleep. Nothing you love has become less real tonight. The ground still holds you. The walls still keep out the cold. The sun will still rise, a little later than it truly rose, its light a little old, but it will rise. What has changed is only that you can now feel how much more there is inside the ordinary than the ordinary ever admits. You spent your whole life inside a reality you thought was plain and closed and finished, and it turns out to have been strange and open and unfinished all along, cracked through with windows onto something vast, and you simply hadn't been shown where to look. Now you have, so rest. Let the weight settle into the bed, the gentle, endless fall the mattress is catching. Let the old light of the lamp reach your eyes a fraction of a second late. Let the walls be as porous and the space be as restless, and the whole cracked, luminous, half-hidden universe be exactly as strange as it has always been. You don't have to hold any of it up. You only have to lie still inside it, for a little while, one small warm crack of awareness in a reality far vaster and more open than it lets on, awake enough for tonight to have seen a few of the seams. That is enough. You do not have to solve any of it, or understand every step, or hold the whole strange architecture in your mind at once. It is enough to have felt for one evening how thin the ordinary surface really is, how much wonder was folded into the plain facts of your weight, your walls, your light, your fridge, your window, and to carry that quiet astonishment with you down into sleep, like a warmth you didn't know the day contained. Close your eyes. The cracks will still be there when you wake, patient, luminous, and every bit as real.